Okay, Buddha, let's start. Let's start. Can you hear me? Can you hear me? Can you hear me, Buddha? Okay, thank you. Okay, let's start. So, as you told before, I'm going to discuss domain and range, about domain and range at the beginning. Okay. Then later I have given a worksheet. Then I need to discuss that one because there are some special questions, there are some advanced questions. Then I need to discuss that one as well. Okay. So very first, I'm going to discuss about domain and range again. Domain and range again. Okay. Okay. Now, initially I told you about functions, no? So I introduced function y equal fx. Y equal fx. This is function. A function. So in this function, here this is independent variable. So then why we call dependent variable? Dependent variable. Usually we denote by x now. Here usually we denote by y. Okay. This is independent variable and dependent variable. So again possible x values. Possible x values. We say domain. We denote by df. We denote by df. If you get any trouble, just let me know. Okay, you can just drop me message or you can call me. Just ask questions. Okay. Now here possible x value we call domain and possible y values we call range. We call range. So here possible y values here this depends with x. That depends with x, no? Therefore, when find in domain, you have to think about possibility of x. When finding possible y values, you have to think possibility of y. So here, there are three conditions. Here we have three conditions. We have three conditions to discuss. So one thing, okay, one thing, see this. One thing, no denominator zeros. No denominator zeros. That is one thing. Another thing, within square root, non-negative. Non-negative. Another condition, within logarithms. Within logarithms, always positive. Positive. So here we have three conditions. So when getting domain, you have to think about these three relations. You have to think about those three relations. Okay, at the beginning you just write it. Just write it. Okay, first you write this part. Just revision, na? Yeah, revision session. Just write. These conditions I have given before, okay? These conditions I have given before. Okay, now you go to this one. Just write that one as well. No denominator zeros, within square root non-negative, within logarithms always positive. Within logarithms always positive. Write that as well. Okay. Now let's do one by one. Let's do one by one. Now you think about this. You consider a function we call polynomial function. We know polynomials, no? Y equal x plus 1. Y equal 2x minus 1. Y equal x squared plus x plus 1. Y equal x cubed plus 3x minus 1. All these are polynomials, no? Then when you consider this polynomial, we can't see any denominators. We don't have any square root. Again, we don't have logarithms, no? Therefore, here all x values are possible. Then all case, domain we say real set. Then all x values are possible. Always remember, for polynomials, domain is real set. Domain is real set. Then remember, for all polynomials, the domain is the real set. Is the real set. Then remember, for all polynomials, domain is the real set. Consider y equal x to the power 4, 3x minus 1. Y equal x times x minus 4. Y equal x squared plus 1, x minus 2 times x. All these are polynomials. All these are polynomials. Then such case, domain is the real set. Domain is the real set. You better write that examples. Just write. If you get any trouble, just let me know. For all polynomials, the domain is the real set. Domain is the real set. So this point, very important point. Okay. So now let's move to further. Now just see, consider rational functions. Now see rational functions. Y equal 1 over x. Y equal 1 over x minus 1. Y equal 1 over 1 minus 2x. Y equal 1 over x minus 1 x minus 2. Y equal x plus 1 over x minus 2, x minus 3, x. We call these are rational functions, no? Rational functions. So rational functions, we have denominators. Then we have to think about denominator zeros. We have to think about denominator zeros. Okay. Now here, denominator zeros impossible. Remember, for rational functions, remove denominator zeros. You have to remove denominator zeros. That's the thing. So identify for all polynomials, domain is the real set, but for rational, we have to remove denominator zeros. because we have three conditions. When finding domain, we have three conditions. One is we need to remove denominator zeros. Second thing, within square root non-negative. Third thing, within logarithms always positive. Okay. Then here, usually domain, usually real set, but we have to remove denominator zero. Then you remove denominator zero here. Then here domain, usually real set, you have to remove here denominator 0, 1. Here domain, usually real set, you have to remove denominator 0, that is half. Here domain, real set, you have to remove denominator 0, here we have 1 and 2. Then here domain, real set, you remove 2, 3, 0, 0, 2, and 3. That is our domain now. Okay, just write the examples. Point very important. For rational functions, remove denominator zeros. This is for domain. This is for domain. This is for domain. Okay. Now, if you get any trouble, let me know. As I told you, I think you have some difficulty with finding domain and finding range. Okay. Now let's move a little further. Now you see this. Now you see this. You think here we have y equal 1 over x plus 1 over x minus 1 plus 2x minus 1 over x plus 2 kind of thing. We have added three polynomial, three rational functions, no? So anyway, when finding domain, you have to think about, we need to eliminate denominator zeros. We have to think about that. Therefore, this case, here denominator 0 is 0. Here denominator 0 is 1. And here denominator 0 is minus 2. So you put that into one set and remove that set with real set. So that is our domain. This is our domain. Okay. Then consider y equal x minus 1 over x plus 1 plus 2x minus 1 over 1 minus x plus 1 over x, 1 over 2x, 1 over x plus 5. Again, this is rational type. Rational type. Therefore, when you get in domain, first you select real set, then you remove denominator zeros. Here we have one denominator 0 minus 1, and here we have one denominator 0 1, and here we have one denominator 0 0, and here we have one denominator 0 minus 5. Then you have to remove all denominator zeros. Okay, write those examples again. If you are in trouble, let me know. So which one put the third domain? That means this one, no? 1 over 2x, no? Is the one? Third one. This one. Okay. Okay, see that? So here we have 1 over 1 minus 2x now. 1 over 1 minus 2x. Then you get denominator here. So that is 1 minus 2x now. Now you equate that to 0. Equate that to 0. Then 2x equal 1. Then x equal half. This is our denominator 0. So here we have to remove real value. We have to remove half. That is our denominator 0. Okay. Okay. Complete this part. Okay. Now you do this one. Huh? You do these questions. You try to find domain. Okay. You write domain. At once you just write. Okay. Now y equal 1 plus 3x minus 3x. Y equal x plus 5 times x minus 3. Y equal x plus 1 of x plus 2. Y equal 2x minus 1 plus 1 of x minus 1. 3x squared plus x minus 1 over x times x minus 5. Okay, just write domain. Y equal x to the power 4 plus 2x minus 1, 1 over x, 1 over x minus 5, x plus 1 over 2. Okay, you take time to write domain. Think and do. Huh? You just think and do. Okay, first write this one. Huh? First write this one. You have. Okay, just write. Complete it. First complete it first. Okay. Now you try these questions. Just try these questions. You just write domain. Okay. I'll give you a few minutes. Complete them. First, you identify the function. If the function is polynomial, then domain is the real set. If the function is rational, then you have to think about removing denominator zeros. No? Then you think about denominator zeros. Then remove from the real set. Complete. Drop me message when you're done. Just try. Okay. 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 Now check your answers. Here, these two polynomials, then domain is the real set. Here, this is rational. Here, domain, real set without denominator 0 minus 2. Then here, domain, real set, you have to remove denominator 0, 1. Here, domain, by the real set, you remove denominator 0, so you have 2, 0, and 5. Then here, domain, real set, here we have one denominator, here another denominator, here 2, that is not equal 0 surely. Then here the domain, that's the domain. Check your answers. Huh? Okay. Now let's move a little further. Now again I told you, when you have functions, you have to think about square root and denominators and logarithms. Okay. Now see this one. Consider irrational expression like y equal root x. That is we call irrational one. Y equal x minus 1 root. Then y equal 1 minus x root. Y equal minus x plus 1 root. Y equal x minus 2 root. Y equal 2x minus 1 root. These are irrational expressions, no? Because they are irrational expressions. So if we have irrational expressions, here within square root, we have to take non-negative values. Non-negative value mean greater than or equal 0 values. Okay. Then when finding domain for this type of expression, you have to think about within square root value must be positive. Within square root value must be positive. Now here, within square root x, no, then x value must be greater than or equal 0. Greater than or equal 0. Now here this case, x minus 1 is the within square root value. Take greater than or equal 0. Then here corresponding to that, put other side x greater than or equal 1. No? That is inequality. No? Inequality. Then here within square root 1 minus x greater than or equal 0, then corresponding value 1 less than or equal x. Here this case within square root x plus 1 greater than or equal 0, corresponding value x greater than minus 1, greater than or equal minus 1. Here x minus 2 greater than or equal 0, x greater than or equal 2. And here 2x minus 1 greater than or equal 0. Then here subject x greater than or equal half. No? These are the domains. These are the domains. Okay, write those examples. Write those examples. First, you identify this logic. So we have to think about square root. We have to think about rational types. We have to think about logarithms. Still, we discuss about polynomials, rational functions, and then have to discuss irrational expressions. Okay. Let me know when you finish. Huh? Let me know when you finish. So anyway, you identify here we have irrational relations. So irrational mean usually square root relations. Usually we say surds. Then such type of expression we have text within square root positive or positive or zero values. That means we have to remove non-negative values. We have to remove negative values. Get that idea first. Okay. Okay with that. Okay. Okay. Now you try this. You try this. You try these questions. Y equal x plus 2 root. Y equal 3x minus 1 root. Y equal 1 minus 3x root. Y equal 4x plus 3 root. Y equal x plus 5 root. Y equal 6x minus 5 root. Y equal 7x plus 2 root. Okay, you just try them. Just try them. The logic, you have to remove denominator zeros. Okay, try them. Take time. Let me know when you're done. No hurry, take your time, think and do. Just think and do. Do we have to subject text and write the domain? No, no, Puta, no need. So this expression enough. Okay, this expression is enough. No need to subject text. Find when find in range, we have to subject text. Okay. So this expression you take as it is, and you think what are the restrictions? We have three restrictions. We need to remove denominator zeros. Again, we need to remove within square root negative values. Again, we need to remove within logarithms negative values and zeros. That's it. Okay. Did you get it, Mihin? Okay, Puta. Okay. Continue. Let me know when you finish. Okay, I think time's enough. Now check your answers. Here x plus 2 greater than or equal 0, x greater than or equal minus 2. Here 3x minus 1 greater than or equal 0, x value greater than or equal 1/3. Here 1 minus 3x greater than or equal 0, then x less than or equal 1/3. Then 4x plus 3 greater than or equal 0, then x greater than or equal minus 4/3, minus 3/4. Then here x plus 5 greater than or equal 0, then x greater than or equal minus 5. Then 6x minus 5 greater than or equal 0, x greater than or equal 5/6. Then here 7x plus 2 greater than or equal 0, x greater than or equal minus 2 divided by 7. Definitely that is greater than or equal 0, okay? Minus 2 divided by 7. These are the domains. So for polynomial functions, no worries. We can just say real set is the domain. For rational functions, we have to remove few values. But for irrational expressions, this type of surds, we have to remove many values. No? So we have to take within square root positive and zero values only. Positive and zero values only. Okay, check your answers and complete. Okay, I think time's enough. Now let's move one step further. So now you take this, just take this. Now consider y equal 1 over x plus x plus 1 root. 1 over x plus 1 root. So that is just hybrid type version function. No? We have rational type, we have irrational type. Both we have. Now for this case, you have to remove denominator zeros. It's not equal 0. And for this case, you have to take within square root positive values. X plus 1 greater than or equal 0. Then x greater than or equal minus 1. No? So when you consider that on a number line, here value greater than minus 1, greater than or equal minus 1. Here are the possible values. So again, we have to remove x0 value. You remove this one. Okay. Then domain, we write x greater than or equal -1 and x not equal 0. X not equal 0. We better write within curly bracket. Okay. Further, you better write this, say, here domain, the x element of real set. Here x such that, here x such that, here x such that x greater than -1 and x not equal 0. So we have combined functions, combined function. Further, you see y equal x over x minus 1 plus 1, 2 minus x. Take this relation. So here you have to remove denominator zeros. Then x not equal 1, no? You have to remove denominator zeros. And for this case, 2 minus x greater than or equal 0. Here x less than or equal to. X value less than or equal to. Now better to mark on a number line. Here value less than 2. Here mark 2. Less than or equal to. Here the region. And further we have to remove 1. So 1 somewhere here. You have to remove that one. You have to remove. Don't shade this one, okay? This is a whole. Therefore, domain x real value. Here x definition, x real value, x such that x less than or equal to. And you have to remove x not equal 1. You have to remove 1. Okay, do that examples. Just do. If you have any trouble, let me know. Here, all we write within curly bracket. All we write within curly bracket because this is a number set. So set we write within curly bracket. So we have defined x value. X values are real values. Here x such that x value less than 2 and x not equal 1. X not equal 1. That's how we write. So here x real value x such that x greater than -1 and x not equal 0. X not equal 0. X less than or yeah, x values. This is wrong, no? So x goes to here. Here it is. Huh? X value is less than 2. Then but answer is correct. Huh? Here 2 minus x greater than 0 means x value is less than 2. Now x value is less than 2. and x not equal 1. Okay, I'll give you 2-3 questions. Now you come to this. You try y equal 1 over x minus 1 plus x plus 2 root. You try this. Y equal x plus 1 over x minus 1 plus 3 minus 2x root. Y equal x over x plus 1 plus 1 minus x root. Okay, you just try them. Just try them. Take time. You think and do. Check whether we have denominators and check whether we have square root. So within square root, values must be positive, and within when we have denominator, we have remove denominator zeros. Then finally, you write final answer. Just let me know when you're done. If you can write at once, you can do. If you can write at once, you can do. Okay. Now let's see. Now let's see. Here you remove denominator 0. And here, x value is greater than or equal minus 2, no? Let's see that on a number line. Here, value greater than minus 2. Here, not equal 1. Here the set. Then you write domain x real value, x such that x greater than or equal minus 2 and x not equal 1, no? X not equal 1. X not equal 1. No need to get number line, but you better to mark that on the number line, then we can easily identify the regions, no? Then no need to mark this on a number line. But anyway, you better to mark, okay? That is not compulsory. Okay. Now here take x not equal 1. Here 3 minus 2x greater than or equal 0. Then here 3 over 2x. Then check that. Here value less than 3 over 2. So here x not equal 1. 1 somewhere here, no? Then you make a hole. Then domain x element of real set x such that x less than or equal 3 divided by 2 and here this is AND operation. X not equal 1. X not equal 1. Okay. Then last one here. X not equal minus 1. Here 1 minus x greater than or equal 0. X value less than or equal 1. Then mark that on a number line. Here value less than 1. 1 somewhere here. Less than or equal 1. Then here not equal minus 1. So you remove this one, make a hole. Then domain x real value, x such that x less than or equal 1 and x not equal minus 1. Here the domain. Complete. Okay. If you get any trouble, let me know. So if you can write this one at once, just write. We have conditions now. Using those conditions, you can write. Okay, I think time's enough, right? Okay. Now let's do further few examples. Now you come to here. Now just take this. Now you consider y equal 1 over root x. We have to think when we have square roots, we have to remove negative values. And again, when we have denominators, we have to remove denominator zeros. Then here we have square root as well as denominator 0. Then here x not equal 0. Here within root value must be positive or 0. But when you consider both together, you just write x greater than 0 only. X greater than 0 only. Here the domain now. Then y equal x over x minus 1 root. Now here we have square root in denominator. Then we have to select positive values within square root, no? Then here take x minus 1 greater than 0, no equal sign here, okay? No equal sign. So if we get equal sign, then that will be denominator 0. We have to remove that one, no? Then here x greater than 1. Then y equal 1 over x plus 1 root. Then x plus 1 greater than 0, x greater than minus 1. Those are the domains. Those are the domains. So further you see y equal x over x minus 1 plus 1 over x plus 1 root. X plus 1 root. Here for this case, x not equal 1. And for this case, x plus 1 greater than 0 don't get equal 0, because when we get equal 0, we get denominator zeros. Then x greater than minus 1. You better to mark that on number line. Here minus 1, value greater than minus 1. But equal 1, you have to neglect. Make a hole here. Therefore, domain, you better write x element of real set x such that x greater than minus 1 and x not equal 0, x not equal 1, x not equal 1. Okay, do those examples. Anyway, you have to think about when getting domain, we have to remove denominator zeros. And again, you have to check within square root non-negative values. Okay, complete. Okay. Now you do these questions. You try. Okay, just do them. Just do them. Let me know when you complete. Okay, check your answers. 2x plus 1 greater than 0. Then x greater than minus half. Here 1 minus 3x greater than 0. Less than 1/3. Here x plus 2 greater than 0. X greater than minus 2. Here 2 minus x greater than 0. X less than 2. 3 plus 4x greater than 0. Minus 3/4. These are the domains. Check your answers. Check your answers. Okay. Any problem? Okay. Okay. Now let's move a little further now. Now you take this example. Take this example. Now you consider y equal root x plus x minus 1 root. Now here we have two irrational values. We have two irrational values. So for this part, x greater than or equal 0. For this part, x minus 1 greater than or equal 0, x greater than or equal 1. Then here real number line, value greater than 0. Value greater than 1. So here you have to think about common region. You have to think about common region. So here 0, here 1, value greater than 0, greater than 1. Then common region will be greater than or equal 1. No? Then domain, x real value, x such that x greater than or equal 1. Here it is. You have to think about common region. Common region. Take y equal x minus 1 root, x plus 1 root. Take this. Then here x greater than or equal 1. Here x greater than or equal minus 1. No? Here x greater than 1. Here greater than or equal minus 1. So mark them on same number line. Here value greater than 1. Here value greater than minus 1. Then here the common region greater than 1. No? Common region greater than 1. Therefore write domain x real value x such that x greater than or equal 1. Here our domain. Okay, write those examples. Okay, if you have any problem, let me know. Okay. After that, you see y equal x minus 1 root plus 1 minus x root, 1 plus x root. Okay. Here, say 1 minus x. Now for this case, 1 minus x greater than or equal 0. That means x value is less than or equal 1. Here 1 plus x greater than or equal 0, x greater than or equal minus 1. We have to take AND operation, and mean intersection. Okay. Now x value is less than 1. Here x value is less than 1. Here 1 is here. Then x value is greater than minus 1. Now greater than minus 1 for this region. Then common region, here this is the common region. X in between minus 1 to plus 1 is the common region. That is our domain now. X real value, x such that x in between minus 1 to plus 1. Okay, take this example as a same procedure. Okay, we think about same procedure, but here we have two functions, that is combined functions. Therefore, one by one we have to think. One by one we have to think. Thereafter, get common region. Get common region. Okay, complete. See another example. Y equal 2 minus x root 3 plus x root. Then here for this 2 minus x greater than or equal 0, x less than or equal to and mean intersection 3 plus x greater than or equal 0, x greater than or equal minus 3. Now mark that on number line. Here minus 3, here less than 2. Then common region is this. Then here our domain. Minus 3 to 2 region. That is our domain. Do it. Okay, here you clear this one. Okay, so here within this square root value must be positive and this square root value must be positive. That is AND operation, not union. Okay, so usually we consider say this one first. So in mathematics O operation union, AND operation intersection. So AND operation intersection. AND operation intersection. Therefore, here this case, here within square root this value positive and Within square root, this value must be positive. Then we consider about AND operation, not O operation. We consider AND operation. AND mean intersection. Intersection. Then here, value greater than less than 2 and value greater than minus 3. We consider AND operation. AND operation. Okay, complete it. Okay. Now you try these questions. You try these questions. Anyway, here we do same procedure. Okay. We do same procedure. We have two terms. No? We have two terms. Then one by one you have to analyze. Finally, you get common region. That's it. Okay, you try. Okay, try them. Take time. While doing, you check your answers. Okay, check your answers. Check your answers. Okay, third one. No? Okay, third one here bata me. Root x no. Root x, then x value greater than 0 region. Then minus, don't worry about this minus sign. Here 1 minus x. For 1 minus x, x coefficient negative, that means you have to select less than 1 value. Less than 1 value. Here greater than 0 value, here less than 1 value. Less than 1 value, greater than 0 value. Then the common region 0 to 1. Then x element of real set, x has get x in between 0 to 1. So I did this at once, but you better to select this one. You better to select x greater than or equals 0 here. 1 minus x greater than or equals 0. Then value less than 1. Here value less than 1, value greater than 0. Then combine it. Combine it. All are done same way. All are done same way. So if you can't write at once, you better to split it. So each square root, you think about each square root, then take positive values. Okay. Complete. Okay, shall we move further? Shall we move further? Okay, okay, okay. Now we know how to get domain, no? So we have especially three restrictions. We have three restrictions. So one is we have to remove denominator zeros. Second one is we have to get within square root positive value of 0. And within logarithms, we have to take only positive values. Within logarithms, we have to take only positive values. Okay, see this one. Consider y equal log 2 base x minus 1. Then you take this one, x minus 1 greater than 0. We can't get 0 values. Always positive values we have to select. Then x value greater than 1. Here the domain. Y equal log 10 base 1 minus 2x. Here take this 1 minus 2x greater than 0. Don't take equal value. Then 2x 1 x less than half. Here domain. Then see y equal x log x minus 1 x plus 1 10 base. Here for this x not equal 0 and for this x plus 1 greater than or greater than 0, then x greater than minus 1. Then when you consider these two at once, here value greater than minus 1, here value not equal to 0. You make a hole here, then finally domain x element of real set x such that x greater than minus 1 and x not equal 0. No? X not equal 0. That's how we write domain. Okay, write those examples. Write those examples. Okay. Now same thing like square root, but here we don't get equal sign, no? So for square root, we can take equal sign, but when we have square root in denominator, again, we neglect that equal sign. Here, within logarithms, all values must be positive. Then when we get in domain, we have three conditions, no? We have three conditions. So one, within square root, non-negative, within logarithms, must positive, and no denominator zeros. We have three conditions. So we have to think that. So by considering all these cases, you can think and you can extract domain. No? You can select domain properly. Okay. Now let's move a little further. Now, see this. Now I told you, when finding domain, we think about possible x values, no? Therefore, similar way, when finding range, we have to think about y values. That is with respect to x. That is with respect to x. Finding domain, very simple thing. Finding domain, very simple thing. So because in a function will be given y subjected format. Your function given y subjected format. So then you can easily find now domain. Now when finding range, we have to think about possible y values. Such case, we have to subject x. Such case, we have to subject x. Okay, when finding range, we have to subject x. But the thing is, easily we can't subject x by any function, but some functions we can easily subject x. But some functions subject in y, subject in x is too difficult. So such case, it is difficult to find range. Therefore, let's do few examples finding range, but we can't do everything. Okay, we can't do everything, but we can do up to some limit. Up to some limit. Okay, now see this. So when finding range, when finding range, subject x to find possible y values. With the following conditions. So first, when finding range, first you have to subject x. Then you have to consider possible values. We have three conditions. Same conditions that what we discussed previously. That means no denominator zeros, no within square root negative values, always logarithms positive. Okay, you have to take same conditions. First one, no denominator zeros. Two, within log positive. Three, within square root non-negative. Here are the conditions. Okay, you better write it. So these things I have given before, but anyway, so you have to remember these things. Again, just write as a revision. As a revision, just write. Okay. Now let's see few examples. Now you follow that procedure. A function y equal x plus 1. Let's say 2x plus 1. So I'm going to find range now. I'm going to find range. So here you subject x equal y minus 1 over 2. No? So here we don't have any denominator, we don't have any square root, we don't have any logarithms. No? Therefore, range possible y values, any real value possible. Here range. Y equal x squared. So now you subject x, a second example. Then x squared, x equal plus or minus root y. Now we get square root value, no? We get square root value. I told you square root value must be positive or 0. Then y greater than or equal 0. Then range, here we denote by Rf, y element of real set. We discuss about y values, no? Finding range means we discuss about y values. Then y real value, y such that y greater than or equal 0. Here this is our range. So here same thing we can write positive real value is 0. Okay. See another example, third example, y equal 1 over x minus 1. Now you subject x minus 1 over y, x equal 1 over y plus 1. Now you see we have denominator values. Therefore now range, usually real set, we have to neglect denominator 0. So here the range now. So likewise we can extract range. Okay, write those examples. You follow that step. That means you first subject x. First you subject x. Then you think about possible y values. Then you think about possible y values with previous three conditions again. So range notation Rf. Then we think about possible y values. Therefore, here we write y real value, y such that y greater than or equal 0 with y variable. Okay, here we write with y variable because we think about range. Okay, do examples. If you get any problem, let me know. Okay, normally finding range somewhat difficult, but these cases very easy. But there are some functions we can't subject x easily. So if we have many x terms, then we can't subject x now. So such case, it is too difficult to find range. But for now, you think about different functions. You think about many different functions. Complete. Okay. Now I think time's enough. Then let's do few exam questions again. You go to these questions and you try to find range. Take time. Take time. First you have to subject X, then you have to think about possibilities of Y. So we have three conditions. We have to remove denominator zeros. Within square root values must be non-negative. Within logarithms values must be always positive. Here we get denominators, we will get square roots, sometimes we get logarithms, but these cases not you can't see logarithms. But anyway, with those three conditions, we can identify range. Complete. Take time. Let me know when you're done. If you can subject at once, then you can do. No hurry, take your time. Do alone. No hurry, take your time. I'm also doing, but you take your time. Continue. First, you have to subject X. Then you have to think about expression. If you have denominators, neglect denominator zeros. If you have square root, within square root, values must be non-negative. If we have logarithms, then within logarithms, values must be positive. That's it. So at the beginning, you have to subject X. So here we have denominator 0, x at y equals 0. We have to remove. Then all rational type we can see here just like r minus 0, no? R minus 0. We have to remove zeros. That is our range. Okay, complete. I think time is enough. So now today I discuss some trouble area in function. Okay. That is about finding domain and finding range. Finding domain and finding range. Okay. So I gave you a worksheet. So I have given a worksheet. No? So you take some time, no hurry. You take some times that contain functions and finding range, finding domain, finding range. There are some special functions also given. But anyway, you try to do it. It is somewhat hard. It's somewhat hard, but don't worry. You just try. No need to do everything, but you try to do. Okay. Then you go through previous all sections again and again. You go through your theory note and you try to do that one. Then again, it contains logarithms, exponentials, and so on. You try, yeah? You take some time. So later I'll discuss this one. I'll discuss this one. Then you can clarify all the difficulties in this worksheet. Okay? Okay. පුතා මම ඔයාලට මේ වෙබ්සයිට් එකට රෙජිස්ටර් කරලා තියෙනවනේ හැමෝම. ඒ වෙබ්සයිට් එක ඔයාලට පරණ කන්ටෙන්ට්ස් ඔක්කොම ටික තියෙනවා. හරිද? දැන් මම දිගටම මේ වෙබ්සයිට් එකට මේ ලින්ක් එක දාන එකයි ඒ ඔක්කොම රෙකෝඩින්ග්ස් ටික දාන එකයි කරනවා. ඒක ඔයාලා ඒක ෆැමිලියර් කරගන්න මම කලින් ඒවා ලෙසන් වයිස් තමයි ෂෝට් කරලා තියෙන්නේ. ලෙසන් වයිස් මම කරගෙන තියෙනවා. හැබැයි මේ ලෙසන් එකෙන් ලෙසන් එකට ඔක්කොම කරන පිළිවෙලට තමයි යන්නේ. අපි දැන් ඉන්නේ polynomial functions. We are doing polynomial functions no. Then under polynomial functions last will be the last session. හරිද? එතකොට polynomial function එක අන්තිම එක ඒ විදිහට එන විදිහට තමයි තියෙන්නේ. ඔයාලා වෙබ්සයිට් එකට ගිහිල්ලා නිකන් just follow කරන්න. දැනට ඔක්කොම ටියුටෝරියල්ස් ටික අප්ලෝඩ් කරලා තියෙනවා. ඔයාලට hard copy එක හම්බුනේ නැත්නම් ඒක මට කියන්න. hard copy එක මම එවන්නම් post එකේ එවන්නම්. කොහොම වුණත් PDF ටිකත් ඒකේ තියෙනවා. හරිද? එතකොට ඔයාලට කිසි දෙයක් මිස් වෙන්නේ නැහැ. එහෙනම් one by one කරන්න අපේ normal A level එක ගත්තාම A levels somewhat hard. හරිද? එතකොට අපිට හැම වෙලේම answers එන්නේ නැති වෙන්න පුළුවන්. හැබැයි ඔයාලට continuously මේක engage වෙනවා කියන එක තමයි මාර important. ප්‍රශ්න આવුත් මට කියන්න. ඕනේ ප්‍රශ්න මම solve කරලා දෙන්න. ඊට පස්සේ ඔයාලා පුළුවන් තරම් මේ දේවල් repeat අහපව බලන්න. බල ඉස්සරහට යන්න. මේ දෙක තමයි මාර important එක. එතකොට ඔයාලට අද මම මේ live session එකේ කරේ මට especially මේ කියපු section එක finding domain finding range එකේ difficulty එක තමයි මම අද discuss කරේ. ඒතර ඔයාලට තව මම session එකක් මම upload කරනවා. ඒක අර polynomial එක්ක තියෙන part එකක් තියෙනවා. ඔයාලත් ඒක through යන්න. ඒක through යන්න අපි ඊළඟ date එකේ අපි ඒකේ තියෙන difficulties ටික අපි discuss කරමු නේද? Okay. That's all for today. Okay, then see you. Good night.